Hello everyone and welcome to the channel. I hope everyone is doing good. So in today's video we are going to look into the scenario based interview question on the RAG. In the previous video we have discussed about the direct question on the RAG from the beginners to advanced level, but this video is going to be specific on the system level and on the scenario based level. So if you combine these two videos, my previous video and this video on the RAG interview questions, you will get almost all kind of question and you will be able to crack the any kind of RAG interviews. So we'll proceed with this video. Before this, please subscribe to our channel, share my video and channel to your colleague who want to move their career into data engineering path or who want to excel into the data engineering path and also into GenAI pipeline. So the first interview question on the scenario based on the RAG is like your RAG system gives hallucinated answer and what you would debug to get into the root cause of this and try to solve this. So this will be a very generic but a scenario based question because you would have described your RAG project, and from there the question can come that your system is giving hallucinating answers. So what will be your step? Which all steps you are going to debug? So before approaching this question, you need to answer it like there are few factors, few areas which governs the hallucinating answers. So we should look into each areas one by one, and accordingly we should proceed with our solution. So the areas are like bad retrieval. There can be bad retrieval. There can be poor prompt design. A context overflow is happening. We'll look into each in detail. Weak re-ranking, wrong chunking strategy, and LLM limitation. These are few topics, or these are the few areas which governs this kind of problem statement. So now we'll look into each of this and we'll try to see how we'll debug this each topic and how to get into the solution area. So our first area was like irrelevant retrieval of the chunks. So verify the retrieved chunks, the chunks which you are getting as an output. What are the confidence level of that chunk, and you need to verify that chunks. So the first thing is your vector database retrieving the correct information? So everything goes into the information which you provide from an external source, and that external source provider is through a vector database. So is the vector database retrieving the correct information? This is the first level of debugging you should do. So how you will get all this information? You need to look into the log of the user query, which kind of query the user is generally asking. What are the retrieved chunks? What is the similarity score? There are Python command by which you can check the similarity score of the chunks. So these are the debugging areas. You need to see the user queries, retrieved chunks, and the similarity score. And with this debugging areas, you will understand that what is the problem statement into this, or is there a problem into this retrieval chunks or not. So there can be irrelevant chunks retrieved. There can be missing like output of this log can be like irrelevant chunks retrieval is happening, or missing important chunks. Like there are some answers which we get from a vector database, but the important answer can be missing out of it, or there are duplicate chunks also, or there the similarity score is very low. So we'll see all this log and we'll get into this of the we'll get this kind of representation. I will come to know like what is going into the retrieve chunks. So this will be our first level of the debugging. Verify the retrieve chunks. So now we'll move to the next level of debugging. So now we have to check, or we have to validate the chunking strategies. So when you will come to know about, you have looked into the chunking information, the information out of that vector database is correct or not. Then we have to look into how the chunking strategy has been taken when you have entered the data into a vector database. So if the chunks are very large, then irrelevant content can come into your context. Context is the answer what you will get from a vector database. So if your chunk size is large, then obviously multiple irrelevant content or irrelevant answers will come out of it. If the chunks are small, then context meaning can break. Like you will not get a complete context meaning. So if the chunks are large, multiple noises will be there. If chunks are small, the exact relevant answer will be missing out from your answer. There may be, not every time. So there are some kind of benchmark, like if your document type or external data which you have entered into a vector database is of legal document, so keep the chunking size between 800 to 1200. If it's a frequently asked question document, like internal company, you're getting a RAG pipeline for the internal company documentation. So in that case, the chunking size is 300 to 500. For the technical documents, it's 500 to 700. These are the general things which people follow while creating the chunk size, but it may vary from each application. So the second thing was to validate the chunking strategies. But if there is a problem into this, so then how you will solve it? You need to go into the recursive chunking. So there is something called recursive chunking. Let me put it here. So the solution for this is the recursive chunking. So what is recursive chunking? So in recursive chunking, we just don't break the sentence or break the full paragraph or the document into a chunk size. We look into the logical recursion into it. Means if there is a paragraph, we just don't break into a big paragraph. We'll look into the sentence in the paragraph. We'll break into the sentence. Then we'll see that if there are some 2-3 sentences combined together to form a meaning, then we'll combine these two sentences and then chunk it. Then we'll go into a paragraph size. So if there's a big paragraph, we go into recursive, we go into smaller size inside that paragraph to create the recursive chunking. So this will help you to build a proper context of your answer, and also this will reduce the size of your chunk. Generally, if you have a paragraph chunking, so it will reduce the size of the chunk, and that will reduce the overall noise which you are getting into your answer or in your context. Now we'll move to the third debugging or the third factors which governs the hallucination in your RAG answers. So the third factor is the kind of embedding. So embedding is nothing. Embedding is just converting your text, converting your document into multi-dimensional vector in a form of numeric representation. So that is embedding. And when we after creating the embedding, we put that information into a vector database. Now, if we do the embedding in a wrong way or wrong context, your overall answer or your vector database storage will be of no use. So we have to look into some domain specific embedding. If you have the external information in a vector database for a specific domain, then we need to go into a domain specific model. So there are few embedding model like BG embeddings, E5 embeddings, OpenText. So there are multiple others. If you Google it, you will get it. The embedding model based on the domain. So what domain your application is, accordingly you can select that embedding domain and you can improve your embedding into that. Next thing what you can do is you can add the hybrid search. Like in my previous video also we have discussed about the hybrid search. So hybrid search is a mixture of one-to-one search, the keyword search, and the search what we do in a vector database, embedding search. So the embedding search is like or we call it a semantic search. In the semantic search, the near to meaning is the focus is to get the near to meaning. So the your data is stored in a vector form in a vector database. So in semantic search, near to that vector representation, you try to get the answer. And there is another search which is the similarities or keyword search. Like for example, you are asking what is IAM role. So it will search for the keyword IAM, and then from the document it will get that answer. But semantic search, the IAM roles, permission, everything will become same. And if the system gets this kind of word in a vector database, it will return you the answer. So first you should there should be a keyword search. If you get the answer into the keyword, you pass it to the LLM and formulate the answer. If you get the output from, if you don't get the output from the keyword search, then you can do it from the vector database search, and then you can retrieve the answer. Hybrid search is bit costly from the compute side because you are doing the keyword search also and you are also doing the vector database search. In case your external database is very big, the size is very big, your external source data is very big, in that case hybrid search will be difficult to perform because it will impact your overall performance, because it's going to do the keyword search also, it is also going to do the semantic search, and combining these two and creating the answer, it will take a lot of time, and this will reduce or this will impact the performance of your RAG pipeline. The other factor to look into is the re-ranking, add re-ranking. So we have discussed this also in our previous video. Like if, for example, you have given a question to your RAG pipeline and it retrieves around 20 documents, like you have it found that the 20 documents have the answer for your questions. So the 20 documents when you pass to the LLM, then overall your answer will have multiple noises. So re-ranking is after getting this set of documents from the vector database, you create the model and re-rank. There's a process from a Python command. You create the re-rank the 20 documents and re-rank into total number of 5. So top 5 or top 2, whatever is your requirement of the application. Accordingly, you can fetch that relevant information from the document and get it as an output. So what you are doing, you are passing the question to your vector database. You are getting a list of answers, or you are getting the list of document which contains the answer. Then you re-rank the document as per the priority, not priority, as per the very much near to the answer, and the highest rank, top 5, top 2, top 10 rank document, you fetch it, pass it to LLM and get the answer. So this is all about re-ranking. I'm not going into very detail of re-ranking because I have already discussed in my previous video. So the other thing is very important, improve the prompt engineering. So like I have also seen multiple people giving the random prompt. So there are ways, there are science behind the prompting. So you can just Google it, you will get that 2-3 types of prompting. And accordingly, as per your requirement, your application, you can put a proper prompt. And I have seen personally by just changing the prompt, your answer changes drastically. So this is also to look into it. Now there is something called like how you will monitor it, like in normal day, how you will monitor the hallucination matrix. So you can use these kind of framework, ragas, dpwell and TrueLens. These are the AI framework which helps you to monitor the performance of your AI pipeline, and also the RAG pipeline. The matrix, what you can like there, these framework gives out few matrices like faithfulness matrix, context relevance, answer relevancy. So you can look into this matrix, you can create a dashboard on top of this framework, and just look into this matrix, or every 2 days or 3 days you can get a report of this matrix, and then you can at least have the understanding that your RAG pipeline is giving the hallucination or not. So once like the vector database need to be refreshed periodically, and if it is not refreshed, hallucination will be a problem in your RAG pipeline. So this metrics will help you to understand the hallucination level also in your RAG pipeline. So after looking into all these factors which I have explained now, you can drill down into the problem area, and once you get the problem area, then solution is very easy. Solution I've just discussed few solutions, but you can also search for the solution. So this will give a very complete answer. So when you are giving this kind of answer, be sure create a story lineup. Try to put it not everything what I have discussed in a single answer. Try to give the ideas through your ideas, like these are the areas we'll look into it. If we get into it, then we'll deep down into it. And in few of the factors, if you are very good to explain, try to focus on that particular factors, so that more questions come from that particular area and you will be able to crack the interview. So now we'll move into the second question. So the second question is more on a scalable system design. Like a user upload 10,000 PDFs daily. So how do you design a RAG pipeline? So 10,000 PDF is being uploaded every day, and then you have to put this information as an external information into your RAG pipeline. So how you will design this pipeline? This is not easy to deal with 10,000 PDF every time in a system. So the interviewer is going to check like how is your clarity on the system design, how you think a scalable system, how you perform the queue architecture. I will come to the queue architecture. How you perform the parallel processing, and what are the ways you handle the failure handling mechanism. So we'll discuss into everything. So before like this kind of system, when you go into the designing process, we just don't ask the you just don't take the 10,000 PDF in a single chunks and try to solve the problem. No, we have to go into the queue architecture. You have to event driven architecture you have to create. Event driven means when an event occur, the first PDF has been uploaded, at that time you start working on that, and the other PDF will be in the queue. So you have to perform a queue architecture I have mentioned here. Like Kafka is one of the event driven framework. You can use it, you can use under any other queue also, but as a data engineering background, I'll prefer use Kafka. Kafka will be able to create the event-driven architecture once the data is uploaded into a Kafka queue. Kafka will have that information in the queue, and you will get the from the consumer side, you will get it from the Kafka, and you will try start working on it. So the first thing what you have to mention is you will go with the event-driven architecture. The second thing what you have to mention is after the event-driven architecture, you have to mention distributed worker processing. Okay, before going into it, like I'm just giving a very descriptive answer for each of the problem statement. In your case, when you just go into a real interview, you don't need to perform, don't need to tell each point. When you will start telling the answer, you will get more question into it, and that will create a very good conversation with the interviewer. So, for example, for this answer, if you have mentioned like you will go with the event-driven architecture, then you will obviously get a question on what is event-driven architecture, how you design event-driven architecture, and that will complete this answer there itself. If you get into distributed worker processing, they will ask you what you will do in a distributed worker processing, why you need it, what libraries you are going to use, what tools you are going to use. So I'm giving a very descriptive answer, but in your case, in your when you go into the interview, then one of these factor will play a great role to make this answer in a greener side, right? Now, you need a distributed worker processing. Like when you consume the data from the Kafka consumer, then you need something to work on a parallel processing, and the libraries which will be used, like you have to read the text out of that PDF and create the information or get the information out of that PDF. So you can use PyPDF, PDF Lumber, you can use the OCR scanner for the PDF. So these are the tool like AWS text extract, Azure. If you're using Azure, there's a form recognizer. So you pass the PDF, it will read the PDF and get the text out of that PDF. So this is the working, like when you've designed the architecture, this is the first thing which will get the data and start working on it. So now you will focus on this area like metadata enrichment. For creating the enterprise level RAG architecture, RAG pipeline, metadata enrichment is very important. Like you are bringing the semantic answer from the hard and then the hard fact, direct answer into a single place. So metadata enrichment is the process of appending contextual, structural details, means contextual answer also, and structural details like keywords, summarization, timestamp to document chunks before it is getting embedded. So when you get a document, you just chunk it, create the embedding and put it into vector database. So before it gets into the embedding phase, during the chunking phase itself, you combine the information, like you combine the contextual information plus you combine the keyword information in the chunks, and then it goes into the embedding side. So metadata enrichment is very important if you are dealing with a large complex system, or I will tell you the large complex searchable documentation system in which you are going to create the enterprise level RAG pipeline. So metadata enrichment, there are process, you can go and look into the Python code. With the help of Python code, you can do the metadata enrichment. This 100% helps in searching in a proper way if your document is very big and very complex. So now you should focus on the chunking pipeline, how you are doing the chunking of your document. So the recursive chunking, which we have discussed in the previous video also, and on also the starting of this video in the first question. So you should focus on reversing chunking. But the important thing is in this kind of scenario, enterprise level RAG pipeline, the chunk overlap should be also mentioned. Like I have mentioned some chunk overlap as 600. Generally, it's recommended that your chunk information should not be duplicated. But in this kind of scenario, chunk overlap is important, because while creating the chunks, the context of the meaning, the context of that scenario or the semantic meaning of that context gets breaks. So to have that continuity, that semantic continuity between the chunks, that chunk overlaps helps in this kind of complex pipeline creation, or when you are going to create this kind of huge data RAG pipeline. So now you should focus on the embedding generation. Like don't go into one by one embedding. When the chunks had been created, then you do the bulk embedding that will optimize the full flow. Then there are few suggestion or few things which industry follows while putting it into a vector database. Like if you are working on a managed services data, then Pinecone is used for one of the vector database. For hybrid search, Vivint is very useful. So these are the recommendation or suggestion for storing in a particular vector database. But the bigger story is when we are getting a huge amount of data. So just have the chunks created and do the embedding in a bunch, in a bigger chunk. So you can define the chunk size also, or in a batch size, and you can do the embedding. Till now you have made the interviewer understand that how you are going to do the system design till the part you are getting the data inside the vector DB. Now once your data is inside the vector DB, so you need to put the strategy for retrieving it. So for the retrieval, like as we have discussed earlier also, for retrieval you have to create a retrieval flow, user query need to be embedding. You have to do the vector search. Which kind of vector search you want to do, that you have to do. You have to merge the result, do the re-ranking, and send to the LLM. So these are the normal path. I think you must have been aware of it. Similar, you must be very much familiar with this flow. So now we are telling the interviewer that how we are going to build the solution for retrieving the data. So this is called retrieval pipeline. Before this, we have just made them understand that how you are going to put the data into a vector database. Now we have to focus on scaling it. Once your platform, the system has been designed, now you will work on scaling that system. What all things you will keep in mind so that your system should scale properly. So for scalable strategy, like these kind of scenario where 10,000 PDFs every day, so you need a horizontal scaling. Kubernetes auto scaling has to be used so that your system level scaling can work. Your worker pool should be there. Like in the second factor, like we have discussed about the parallel processing. In that case, worker pool should be there. Retry queues if something fail in your pipeline. So how you will retry it, and how many times you will allow to retry, and for retrying what information you have to store in the queue, that also need to be designed. So this will help you to scale the like for tomorrow, from 10,000 if it moves to 20,000, your system will not have that processing bottleneck, so that and that bottleneck will not create a problem. Like, obviously that bottleneck will not be created if you move the increase the number of PDF. So these are the strategies you can keep in mind for scaling the systems. Okay. For monitoring purpose, you have to also set something for the monitoring purpose. Like in the first question when we were discussing about the hallucination, so there are few monitoring tools and monitoring metrics you need to look into, which will give you the information that how much of the hallucination has started in your RAG pipeline. We'll see it now. So as I mentioned, for the monitoring, like OCR failure rate. Okay, then what is the embedding latency, how much time it takes to get the system data embedded, what is queue lag, what is vector DB latency, hallucination rate, you can get it from the multiple framework which is available. So monitoring track is important for these kind of enterprise level RAG pipeline. So now we have another interesting question, like how do you reduce the RAG cost in production? So obviously RAG, the process in the GenAI is always CPU intensive also, and it costs a lot. So the major cost driver is when you create or when you generate the embedding generation, vector retrieval, and LLM token. So if we control these three areas, you will be able to reduce the cost in the production. So for the embedding generation, you can have the embedding cache, so it will avoid regeneration of the embedding. You can have the embedding cache. You can have the smaller context for the chunks. You can compress the context by using summarization before LLM. So before moving into the LLM, just don't give the full content of the output of the vector database into the LLM, because that will be a bigger chunk, a bigger context to the LLM, and that will increase your LLM token. Okay, so instead of that, do the summarization and then give that output to the LLM. Use multi-model strategy, like for the smaller kind of questions, you can have the small model. If you have a bigger question, bigger context, then you can go with the bigger model. You can have multi-model with switch clause in your system, that can be done in the RAG pipeline easily. So this will help you to do the reduce the RAG cost in the production. There are a few more factors. One more thing you can do for this costing, reduce the costing in the production. You can do the async processing, like you can perform embedding, OCR, and the parsing in a parallel processing, in a asynchronous in the background, so that it happens in the background. This will not reduce the cost drastically, but obviously this will help in some of the thing. It actually helps in increasing the performance that it can do. So now we are going into the last question. Like I have multiple more questions to discuss, but this video will be going to be very big. So the last question which I'm going to take is, how do you evaluate a RAG system? Apart from this, if you want me to discuss few more questions, you can put it in the comment, or any specific area you want me to explain in detail, then put it into a comment, then I can go into more detail. But for today, for this video, we'll just take this as a last question. How would you evaluate a RAG system? You have built a RAG enterprise level RAG system, but you need to first look into the relevance of this RAG system. So the important thing is we need to check for the retrieval evaluation. The answer what you are getting is how much correct or how near to correct. The first thing, the first matrix is recall at the rate k. So this tells you the total number of true output, correct output, divided by the total number of correct output present in the vector database. Like what is the total number of correct output retrieved divided by total number of correct output is there inside the vector database. So it gives you that number. Precision at the rate k, this gives you like at what level on how much precise your answer you are getting. Faithfulness also gives you the correctness of your answer multiple times when you ask the same kind of question. Answer relevancy is just the manual effort. There is a context relevancy, like your answer is correct, but is it contextually correct or not? That is being checked by this matrix. So these are the few of the manual metrics. Apart from this, you can go into the framework also, which we discussed in our previous question. With the help of that framework, you will also get the relevance of your answer. By these all metrics, you will get to understand that your enterprise level RAG pipeline which you have built is at what level of accuracy, and you can try to every time, like RAG system need to improvement every time in every period, and that will improve the overall system. I hope this, yeah, I know that this is going to be a very long video. You need some time to understand it. But my suggestion is just go into my previous video of the RAG, the interview question, and then come to this. Apart from this, if you have any other questions, you can put it in the comment. If you want me to discuss in any of the topic in the RAG in much more detail, that also I can come up. Or if you want to me to show any of the topics which we have discussed today practically, that also I can do it. But you need to put it in the comment. We'll meet in the new video with a new topic. Till then, be happy and goodbye.